All right, so welcome back. Today in this video, we're going to be doing some more Civil FE exam review, and we are in the static section, and we're going to be focusing specifically on equivalent force systems. So I do have some practice problems for you all. Hopefully you didn't skip resultants of force systems, which is the topic right before. But we want to go ahead and dive into some of these examples. So number one says a 15-pound weight is suspended from a rope that makes an angle of 30 degrees with the vertical. Determine the tension in the rope. Assume a frictionless pulley. Okay. So what information, I always like to start by trying to figure out, what information they give me, and what am I trying to solve for. So, all right, what am I given? Well, definitely given the weight of my object, right? They let me know that my weight is 15 pounds. What else? I am given a visual and of what this looks like. I can see that my string is here. This dark line. I don't know what happened to it. It kind of disappeared, but it's there. And then I can see the angle is 30 degrees from the vertical direction. So just something to note, pretty important. So what are we trying to find? Well, we're trying to find the tension in the rope, right? So the tension in the rope, we can break this up, right? And we can look at this thing where we kind of do like a diagram of what's happening, right? So I know that this thing is coming down, right, because of the pounds. But I also know that there's a force acting up, right? Because it's attached, and that is the tension. Okay, so what formulas do we need, right? Very important that we figure out what formulas that we need so that we can solve this. So one of the formulas searching equilibrium, a lot of choices. So let's not do that. Let's look through our handbook and go to the static section, because typically it's where it would be. And one of the key equations for us is the sum of the forces within a certain group is always going to be equal to 0. So basically that just says that if you have a force going down, there's going to be an equal and opposite force going up, right? All right, so in this case, let's look at the sum of the forces, right? And figure out this one in, figure out this force of tension, right? All right. So the sum of the forces, and to save time, how you want to think about this is how can I create an equation that has the least amount of variables that I need to solve for. So I'm going to walk you through both ways just to show you what I mean by this. So we can look at this and we can say, okay, the sum of the forces in the x direction equals 0, right? And so the sum of the forces in this particular x, well, I don't know, the only force that I see in the x would be T, right? Because you have on this tension force, you have it acting, it's going to the right, some, that dotted line that I just drew in the x, and then it's acting upwards for the y, right? So it's to the right for the x and up for the y. So some of the force in the x would be a positive T, and then what would be my how could I do trig to get the angle, right? Because it's not just going to be T, because it has to be T and then cosine, right, of 60 degrees. Okay. Is there anything acting on the on this as far as in the x? No. So we really can't solve this because you don't want to do a 0 divided by something to get t is equal to 0, because we know t is not going to be 0, or at least we don't believe it will be. So this equation doesn't really help us, right? So let's try in the y. Sum of the forces in the y is equal to 0. Sum of the forces in the y is equal to, okay, negative 15 pounds, right? Because we got the force. It's coming straight down. And then what about T? So then we have plus T sine of 60. What did I choose? Sine. Well, we're trying to find the y value, so that's always opposite, right? Opposite over hypotenuse. The degrees within this, according to the x is going to be 60 degrees. Okay. Yeah, so t sine 60. So, okay, we can bring this to the other side and we can say 15 divided by the sine of 60 is equal to t. All right. So what do we get for that? Oh, t is equal to 17.32 pounds. Answer is C. So we broke that up. So it's a little bit of drawing some diagrams and figuring out where your forces are going and how can you create some equilibrium within this drawing. All right. So let's look at number 2. All right, so a traffic light supported by 2 cables, right? As shown below. Okay. The tension in cable 1 is measured to be 294.8 newtons. What is the tension in cable 2? Okay. Let's look at this. What do they give us? All right. Well, they give us that we have the tension in cable 1. So all right, we have the tension in cable 1. Anything else? We have angles. I'm looking at this thing and I'm like, gosh, it doesn't seem like they gave us much of anything. All right, we have angles and anything else? Nope. So what are we trying to solve for? Well, we're trying to solve for the tension in cable 2. All right, so what are the formulas we need? Well, we're going to need equilibrium. Sum of the forces is equal to 0. And so we draw this out. And so I definitely know that there is some weight here, right? But I don't know what that weight is. So if I do the sum of the forces in the y, I have 2 unknowns, right? Because I have a unknown, the weight of my light, and then I also have an unknown of the y value for T2. So as you're going through, you're going to notice that you want as least variables to solve for when you start working out your equations. So I know that in the y direction, if I do some of the forces in the y, I have a lot of unknowns. More unknowns than I feel like I would have in the x. Why? Well, let's look at it. Sum of the forces in the x is equal to, well, do we have T1? Yes. We know the tension in cable 1, which is 294.8. Okay. But we're looking for in the x direction, so we're going to do cosine of 25. Okay. And then what about for T2? Minus T2, because this value is pointing, this x value is pointing to the left. So that's a negative x value. So T2, and then it's going to be cosine of 15. All right. So to get T2, you're going to bring everything to the other side and then divide by cosine of 15. But I won't. I will take my time with this one and make sure that you fully understand. So we're going to say it's negative 294.8 cosine of 25, which is equal to negative T2 cosine of 15. I just brought that to the other side. Now I'm going to cancel my negative values. They cancel, literally. And then I'm going to say 294.8 cosine of 25. And I'm going to divide everything by the cosine of 15. And that equals T2. All right, then I'm going to plug that into my calculator. And you should get T2 to equal 276.6. And that is newtons, right? Or A. Perfect. Get one more. Number 3. So a 30 Newton weight is connected to the ceiling by 2 ropes. Keep in mind, 2 ropes passing over a frictionless pulley. So you're not worried about the force friction in the pulley, right? If one rope is vertical and the other is 45 degree angle from the horizontal, find the tension in each cable. Okay. So this one is drawn out a little bit more for you. You have T1, you have T2 to the right, and they want us to find the tension in each rope. So what are we given? We're given angles. We're given that it is 2 ropes, not T ropes, but 2 ropes. What else are we given? Oh, we're given the weight of this, whatever this is. Oh, it's just a weight. 30 Newton weight. It's connected to the ceiling. Okay. Why that's there, I don't know. Okay, so, and we need to find tension in each rope. Okay. Easy enough. So let's start. So what formulas do we need? Well, I know that we need sum of the forces is equal to 0 in both the x and the y direction. And how can we start this problem? Well, we can look at this and say sum of the forces in the y direction. I don't know if I want to go that route because I don't know T1. So we'll go back. Do we want to do the sum of the forces in the y or the sum of the forces in the x? Decisions. So what I could do, we'll just start, see where we can go with this. Because I don't know right now. Sum of the forces in the x is equal to T2 sine of 45, right? It's a positive. Okay. And I don't know if I like the way that I wrote that. So, I mean, it could be, I believe the cosine of 45 and the sine of 45 is the same. Yeah, so if I'm looking for the x, then I'm looking for the adjacent, which is cosine 45. Still the same thing. All right, the sum of the forces in the y. Let's take a look. equal to, okay, what's T1? We don't know, but we do know that it's going in the upwards direction, right? And now we know that T2 is going upwards and to the right. Okay, so this is equal to T1 plus C. T2 sine 45, and then we got this force come down minus 30 newtons. Okay, so where do we go from here? Let's just solve for T2 and go from there. T2, because I'm thinking if I can solve for T2, then I can plug it back into my f of x function and see if I get a value. Okay, so T2 is going to be 30 newtons minus T1 over sine of 45, which is equal to T2. Okay. So let's try to plug that back into the f of x and see if we get anything. So f of x is equal to sum of the forces in the f of x is equal to 30 minus T1 over sine of 45 okay, it's all in parentheses, and then if I want to multiply all that out by cosine 45. All right, so when I do that, these cancel and I get sum of the forces in the x is equal to 30 minus T1. T1 is equal to 30 newtons. Okay. Now, plug 30. So the thing about this is now I use that, got a value for T1. Now what I can do is I can plug that number back into T2, or I can take this number, right? T1 is equal to 30 newtons, and I can plug that back into here to get my T2. That makes sense. So 30 minus 30 over the sine 45 equals T2. So 0 is equal to T2. Okay. So T1 is 30, T2 is 0, and so I get my answer to be A. All right, so hopefully that made sense. Sometimes you should never just say T2 is equal to 0 from this first equation, right? You should always, if you come to a situation where you have a bunch of unknowns, write out both and then get it in terms of T1, T2, and plug those values back into the equation to get, a number, right? And once you get a numbered value, then you can go back into the equation to one of your multiple equations and solve to see what the other value is. But you can't just you never want to have assumed that T1 is 30, which in this case, this isn't a normal problem. Normally, you'll have it pointing a little, T1 would have been probably coming out this way on a normal question, but I designed this one just to make you substitute, do a little bit more extra work just to make sure you had an answer. All right, so number 3 was A. This concludes this portion of the statics review, and this is the equivalent force systems. The next section that we'll be looking at is equilibrium of rigid bodies. So if this was confusing to you, feel free, reach out with questions. I'd be happy to go over anything that's confusing for you. I want to make sure that you pass this exam. So